All right, we're almost done. Just got to add a couple more drawables. So the next one we add is a cone. And that is based on pyramid, or it's a pyramid based on code. I don't know what it is. It doesn't matter. Whatever. You see here, we got the geometry. Geometry is of a cone, so it is flat shaded. This cone is actually flat shaded on all of its faces. No smooth shading, all flat shading, all independent faces. So we have a function make tessellated independent faces, and this one is simpler than the other one because it doesn't generate any normals. And then we can use the same function we used for the cube to generate the normals for our cone. So we use pyramid. I should have named this cone or something like cone, but I named it pyramid because that's what we had in the previous one. But anyways, it comes from the original pyramid, except now we make it inherit from test object, so it becomes a lot leaner. And in pyramid.cpp, we add the normal. This one uses color blending. It's going to use a color blending shader together with Phong shading. So every index is going to have its own color. And then we generate the cone. We generate the color for each vertex, and I believe the tip has one color and then all the base vertices have a different color. And so you get blending from the tip down to the base. And what else? Model transform. So we do a little bit of a transform on the model. What do? We squeeze it down in the Y or the Z, and then we set the normals. So there you go. Again, set the shaders. The input layout has position, normal, and color. And that's really it. The vertex shader here is going to take in color now, and that is going to be interpolated, and that is going to be used in here. Pretty simple. You add that in to the factory, and apparently it was weird because I got another commit here. It's called Fix That Pyramid Boy, and what it does, I don't know, but we're gonna find out together, I guess. Is it constant auto tessellation? So it does a couple of things. Uses tessellation distribution to determine the tessellation of the model. So it'll be randomized how many faces on the cube, or not the cube, the cone. And we changed color a little bit here. Yeah, the color has been changed. But the most important change is the one down here. We have to add the constant buffer for the material, and that holds the specular intensity and the power. Without this, the specular highlights aren't going to work, and that is why it was weird. Notice that we don't have material color in here because the color isn't per object, it is per vertex, and so it's handled up here. And if we run that, we get this. We have cones, and they are being flat shaded. All the faces are independent. And what else? Zoom in a little more. Yeah, let's get a good view of a cone in here. Yeah, the cones, and they've got nice. You can notice they've got some nice specular on them too. If you hit them at the right angle, and it looks pretty. So another one bites the dust. We've got one type of drawable left, and that is we want to add texturing with dynamic lighting on a drawable into this scene. We're throwing everything at it. The kitchen sink. So now, because the color is being determined by a texture, again, we're going to need different set of shaders. We're going to need a shader, vertex shader that takes in texture coordinates, and we're going to need a pixel shader that has, a texture and a sampler and takes in texture coordinates and uses them to determine the material color. So the new drawable type is called skinned box, and we're going to need a new type of cube because we're going to need a cube independent textured. So we're going to make it with independent faces. This one is not, although it's called skinned box, it's not really skinned. It's more just going to be every face is independently textured. So that means that we're going to need, again, 24 vertices. And we just call make independent to create those 24 vertices, and then we set their texture coordinates. So skinned box is again what we had before, but we're repurposing it. We're going to inherit from test object, which makes it a lot shorter and a lot easier and a lot sexier. We add sampler in here, and we add the normal texture coordinate here, and we set the normal independence. What do we set? We set the sampler, set the texture, which is going to be kappa, and that kappa is going to be put on all faces. That's why we have it independent, so we can take a single square image and put it on all faces of the cube, which is not what you could do with what we did with the dice or skin texture. A different story. So yeah, input layout has position, normal, and texture coordinate. All the stuff that you would expect. This should not be surprising for you. Again, specular intensity and power. We don't need ambient material color because that is handled by the texture. And that's it. App is where we put it into the factory, and if we run it, you should get exactly what you expect, which is to say we get kappa on a cube. And it was good. It was very good. Now we're going to wrap up just with a couple of fun little enhancements that we make. So the first enhancement is more of like an oversight on my part here. So when we created the pyramid and the cylinder meshes, we actually created them, although we're taking in a distribution per instance, we created those messages in the static part. So that means that every cylinder and every pyramid is going to have the same mesh. But my original intention was for them to all have individual specialized meshes. So I moved that out of the static and I put it into the per instance initialization part of the constructor here. And so now all of these messages for the cylinder and for the pyramid are going to be per instance. Actually, I moved a whole bunch out. What did I move out here for the pyramid? Because there was the tessellation of the cone. Oh, it's just because there's so much to do with the geometry of the pyramid here. So when I moved it all out, it just looks like a lot, but really it wasn't that much. Static index, yeah, the index buffer, that has to be moved out and into the per instance part here. So that's fine. Good. So we do that, and now we have more variety in our models. So you can see here, very high tessellation on this cone, but if we wait for a second, we can probably find a cone with very low tessellation. Yeah, like look at this cone here. It's a very low tessellation. This one is incredibly low tessellation on this cone, whereas this one here is very high tessellation. You can see the same thing with the cubes, low tessellation, not cubes, cones, no, cylinder, word, wrong, cylinder, low tessellation, relatively high tessellation. All right, beautiful. Now the last thing I added is just a little fun thing that I wanted to do, and I did it. So we're just going to look at all the commits. We're not going to build it and run it for every single commit, but we'll look at what I did and we'll look at the final result. So what I wanted to do basically is the ability to control the box materials, attributes, and other things about the box while the simulation was running using ImGUI. So what I did, let's see what I did here. For Drawable, first of all, I add a function to the base Drawable that allows me to query the bindables, the instance bindables, and to find one, and that will allow me to use it to change things about particular bindables. You'll see how that works in a second. So in box.h, I create a function spawn control window. So every box will have its own control window, and I create a function sync material that will synchronize material data. And so now every box is going to hold this material constant with the color and the specular. And in box.cpp. So for the constructor, now that the material constant is being defined in the class, the structure, we just use that structure here in the constructor when we're building our box up. And for spawn control window, what we're doing is we've got controls for color and specular, just sliders. And we run ImGUI, we check to see if any of these change, and if they change, then we call sync material. And what sync material will do is it uses query bindable, which is a function that loops through all the bindables to find the material cbuff. When we get that, we just do a little sanity check to make sure we found one. This should never return false. Should never be a null pointer. And then we update that with the material constants that are stored in our box. Now in app.h, separately I maintain a vector that just has dumb pointers, non-owning pointers to boxes. So I have a separate container that just keeps track of the drawables that are boxes. And I have plans for the future for that. But for right now, what I'm going to do is I'm going to loop through all of those. Well, when I create the app, I loop through all the drawables and I build up my vector of just boxes, pointers to boxes. And down here, just to start off with, I spawn a control window for the front box in the container. And that allows me to control one box in the simulation. And I tested that and it worked fairly okay. So my next step was to be able to select boxes to manipulate. And the way I did that was I added a set, and that's going to be the set of windows that are open for different boxes. So you can have multiple windows, control windows for multiple boxes open. And this is used for ImGUI with a combo box control. And then I put this big ImGUI window thing in here. And all it does is it builds up a combo box of all of the boxes. There's two box words, and it's making the sentence very complicated. But all the drawable boxes, and allows me to select drawable boxes and spawn control windows for them as I see fit. That's what this is about. And then down here, what I do is I loop through all, this is a set of box IDs, control IDs, and I loop through all of them, and for each one that's in the set, I spawn the control window. So the set controls what control windows are open for which boxes, drawable boxes. So that's fun. It's all fun. And then I fix a little bug here with the flickering on, and this is an interesting thing about ImGUI, or about C++, if you will. But the thing is here, what I was doing was these functions here, color edit, slider, and slider, they return true if the control was manipulated, the value changed. And I could use that to check to see whether I want to synchronize or not. But here's the thing. What I was doing is to build up to check to see if any of them changed. I used logical OR here. But let's say you change this one, dirty becomes true. This dirty is true, so it short circuits, and it doesn't call this function, which means that this slider doesn't get drawn in that frame. And so what I would get is I would get flickering sliders whenever I moved them, and that was dumb. So I changed that by not using OR in here. Therefore, I didn't get the short-circuiting behavior, and then I just logically OR'd these three together at the end to check to see, to determine whether or not we are a dirty boy. And if we are a dirty boy, we have to sync. This one is just a little bit of organization. So here, instead of having this ImGUI code chilling out in the middle of our do frame, I pull it out into its own function. Spawn box window manager window. Yeah, the window's in here twice. It's because it's a window that manages box windows. There you go. So now this is in its own separate function, and now the logic for the actual do frame is a lot cleaner. Spawn simulation window, spawn the camera window, spawn the light window, spawn the box window manager window, and then spawn each of the box windows. Spawning the box windows is just looping through our set and spawning all the control windows. So there you go. Now here I make it so that you can close the windows on the boxes, which is nice, which is a nice little feature. So for the box here, spawn control window, I make it return false if the window was closed. And then in box.cpp, when we spawn the window, we have a bool here called open. We pass a pointer to that bool into the begin function, and that will create the window with a close button. And if the user clicks the close button, this bool will be set to false. So then down here, we just return that value. And if it is set to false, so what we do here is when we're spawning our box windows, we spawn it. If the value is true, if the value is false, because I got a not in here, we erase that ID from the set. And so because we're erasing from the set as we're iterating, we have to use begin and end. And we have to keep track of our incrementation outside of this for loop, because that's the way you do it if you want to erase while iterating. Almost done. So here I allow myself to control not only the material parameters, but also the position and the orientation of the box. Test object, what does it do? I make this protected so that the box can access them. And then I add controls to control, you know, theta, phi, etc., etc. It's all good. And the last one, improved box position / control / representation. What does this even mean? What does this mean? All right. So before, these angles, they would just keep building up and building up. So you would get like thousands of radians. But obviously the controls from ImGUI, they only work in a certain range, like say negative pi/2 to positive pi/2. So in order to make these values work within a sane range, we wrap the angles around to within negative pi to positive pi, I believe, is the range that we work in. That's true. That's right. Not pi/2, but negative pi to positive pi. And that makes things look a lot better. And the slider angle here. This one was from 90 degrees range, basically. And I changed this one to also to 180 degrees, which is, you know, negative pi to positive pi. And that's it. That's all the stuff that we did in order to control our boxes. Now let's give it a shot. So here it is. And we have a new window here, the box window, control window, manager window. And if we can select a box number, you can see here we've got 33 boxes or 34. Let's select box number 5. Let's turn the simulation speed down to basically nothing. And there's something in my way. I don't like it. Yeah, get out of my way. There we go. Could probably just move the camera in a little bit too. Probably help get stuff out of my way. Okay, so let's see if we can't mess around with the box. So here's box 5. We don't know where it is, but let's see if we can find it. So let's move around. Let's just pause with spacebar. And let's move the position of the box. I don't see it. Do you see it? I don't see it. What about this one? There it is. We see it. It's moving around. And so now we have it in our sights. And we can change its orientation. Beautiful. Okay. Sure. That looks okay. If I do it just right, you can see, you can see a little bit of specular on that boy. Specular, specking it up. We can change the specular intensity. Oh yeah, it's getting brighter. It's getting darker. It's getting brighter. We can change the power. Makes it more focused, less focused, more focused, less focused. And we can change the material color to something a little more blue. Dabba-dee-dabba-die. Yeah, sure. Beautiful. And that's a box window. We could open another box window. We could close this box window. It's all good. Everything's good in the hood. And I think hopefully you'll agree this is a interesting little test simulation that we've built here. And we have thoroughly explored, you know, at least a basic dynamic lighting system with a single light, point light, per pixel shading, specular. Everything is amazing. But that's going to about do it for this video. As always, if there are things that weren't clear, and there probably are, first thing you should do is you should obviously look at the code yourself, build it, explore the commits. Don't just expect everything to be spoon-fed to you and understand it immediately, because that's not how this works. You got to work for it, number one. Number two is if you still have things you're unclear of, you know, think about them, try to crystallize exactly what you don't understand, and then come to us on the Discord or on the forum. Links are, you know, the URL is at the beginning of every video. People always ask me, what's the link to the Discord? I put that URL at the very beginning of every single freaking video. It's planetchili.net. But anyways, you got questions? You make sure you crystallize your misunderstandings. You think about them before you come to us. Don't just say, I don't get it, because that's not a good question. But you got questions? You come to the Discord, you come to the forum, you ask us. We can hash it out. You can learn more things effectively. You get it? It's cool. And also, play around with this code yourself, or try to implement this code on your own, starting from a previous point and not looking, or whatever. But do program, don't just watch. And yeah, I think you will be able to do it. Probably. I don't know. I don't know you, but I have most of my viewers are smart people, I think, so I think you can probably do it. Anyways, I'm just rambling now. Next video. Probably, haven't decided yet, but probably going to get into loading meshes, because I hate freaking working with these procedurally generated geometries. So, I'm going to be loading meshes, probably using a library called Asimp. The name is amazing. The name alone is enough to sell me on it. But yeah, that's the next video. Thanks for watching. Hope you enjoyed it. If you did, please click the like button. Helps a lot. And I will see you soon with some more Hardware 3D.